All right, so for 2.3, we're going to be getting information from the graph of a function. We're going to analyze the maximum, minima, and the direction, which is going to be whether it's increasing or decreasing, and then we're going to use functions to model optimization, and those are going to be maximum or minimum problems. So I'm just going to apologize in advance for the quality of the first graph that's on there, but we are going to work through that together. So you have this function that is graphed, and it is modeling the percent charge of a laptop battery over a 24-hour period, okay, where 0 is midnight and 12 represents noon. Okay, so you're finding P of 0, P of 9, P of 12, P of 17. When you're finding those, just keep in mind that the height of the graph, that is going to be the value of the function. Okay, so if I'm going to find P of 0, okay, I'm going to go to 0 on my graph, go straight up. This point is right at 80. Okay, and then for P of 9, you guys can either use a straight edge, or I was just using a post-it note. So when I have to estimate, like if I'm going like this with my pen, I will waver a little bit. Okay, so I use my straight edge to just help me find that point so that I can estimate. Okay, so we're going to estimate, this is between 90 and 100. It looks like it's right in between there at about 95. And you can put your approximation symbol. And then I want you to approximate for P of 12 and P of 17. You can post it, or if you grabbed a straight edge, that was to help you. You use your straight edge to help you draw your lines. Okay, so P of 12 should be somewhere around 75. Okay, if you put 76, that's fine. 77. Okay, really somewhere between 74 and 78 would be great. Okay, if you, just so you guys know, if you had a question like this on your test, it would be a multiple choice type question because they don't have the points. Yeah, great. And then there are some where they actually have the points or they have the grid. Okay, so this is an estimation. It's okay if you're in the ballpark. Okay, they don't have to be the exact. This is going to be an estimation. And then for 17, that is correct. So you can grab yourself now, right? I'll just put it in the back. All right, so what'd you guys get for 17? P of 17 is around what? Yeah, around 85, 86, 87, 88. I think one time I did it, I got 85. The other time I got 88. And then will you guys answer B, C, and D? Rocco. Yes, mine right there. I put about 88. Again, 87, 86, 85, all of those are great. All right, and then when you're deciding what's larger, P of 14 or P of 18, you just have to look and see which one is higher. Okay, so we should have got P of 18. Okay, and then there's a few different ways you can write your answer for C. Okay, so find the values of x for which P of x is less than or equal to 70. Okay, so when you are finding those values, okay, we are going to find 70 on the y-axis, and then I'm just going to draw a little line there. And then I'm looking to see what x values that's going to correspond to. Okay, so from here to here, those are all the values that are below 70. Okay, so if I follow this down, it does look to be about 13. Okay, and then you can decide, whoops, spacing a little strange there. If that looks exactly 13 to you, you could put the less than or equal to. Okay, and then for this one, when I was looking at this, to me it looked like it was in between 16 and 17. Okay, so instead of using decimals, I just put that it was less than 17. Again, there's going to be multiple ways that you can write this where they're correct. Maybe you thought it was 16.4, so you put it less than or equal to 16.4. That's fine. Okay, for questions like this where you have some leeway, this would be a multiple choice type question. And what do you know? Your quiz on Friday is going to be multiple choice. Okay, so it's, can you identify these values that are similar? Okay, would they make sense in this context? So yes, if we saw that it was less than 17, we know that 17 is halfway, that would fit in. Okay? All right, and then for the domain and range, we know that the domain is going to correspond to your x values, okay, which is also going to be the input of the function. So sometimes our input might be another variable, and we're still going to have to find the domain today. And then the range corresponds to the y values or the output. Okay, so even if it's not y, we're going to correlate it with that output value. Okay, so for this one, the domain, the lowest value you could have for x is what? 0. Also remember, we're talking about a percent charge, so that also makes sense in context that you have 0 is less than or equal to the value of x, and it can be 0. Or sorry, I said this was the charge. That's going to be your y. This is your hours. Okay, so 0 is midnight, and then it's going to go up to your 24 hours. That it would, we're letting the 12 represent noon. I guess it would go up to like the 23.59 the minute. but you are going to have a point there, like at your 24. Yes, P of X is the function, but the range is going to be your Y value. Yeah, I feel like that one would be open to interpretation as well. Okay, and then your range value is your P of X. So you could write P of X here. So X is your input. The domain is always going to be the input. So in this case, your domain is X, your range is P of X. You could either use Y or you could use P of X in this case. And then the lowest value for this graph specifically is going to be approximately, so we just have to find where this is. Okay, so it is a little bit above 50. What do you guys think? 52? 52, 53? Great. Either one of those are fine. Okay, and I know sometimes like having things that are open to interpretation can be hard for us because we want there to be one right answer. But this is how real data works, right? It's going to be an interpreted answer here. Okay, so as long as you're in the ballpark, you are good. And we just have to know how to find them in both interval and set builder notation. All right, and then we are going to use Desmos for example 2. We can also plug that into the graphing calculator. I do like you to see kind of the difference between them so you can see when it's more useful to use Desmos. And I did post a link for Desmos in your Google Classroom. That is for when you're doing like homework outside of class, because we won't have the Desmos test mode there. Okay, and then when you are putting this in your graphing calculator, you do have to put parentheses on the bottom. And if you want to go back to the 10 by 10 window, you can just go to Zoom and 6 for Z standard. Okay, and then this is your graph. We're also going to plug this into Desmos, and then I'm going to show you what it looks like on another graphing calculator as well. So if you have your graphing calculator, I want you to plug it in there, and then you guys already logged in to your test mode. Okay, and then once you get into your test mode and you have the graphing calculator, you're just going to go to Start Test, and then you can start typing. Okay, so I know a lot of you are familiar with this, but just in case you're not, you can do f of x equals, or you can do y equals. It doesn't matter. Okay, and then you can do the 1, and then the slash is the divided by, and when you do that, it automatically gives you the denominator, so you don't have to worry about putting in your fractions. And it's cool because it will graph it in real time. Okay, so now we can see like really clearly this point's at 0, 1. We can click on some of these points to see what's happening, and then you can like zoom out to see what's happening over time. So as the numbers get larger, you can just scroll along here. They're getting closer and closer to 0, but has it dipped underneath it yet? No. And you could keep scrolling out and you can check that out. On your graphing calculator, the trace feature does that. Okay, and then on some graphing calculators, like it has the TI 84. Sometimes they don't show like those full branches. Okay, so one nice thing about Desmos, sometimes like the pixels in the calculator won't show you that this keeps going. Like this just looks like a little speed bump and you can't tell that it keeps going. So decimals is helpful for you to see those lines. All right, and then we're going to sketch a graph. So if you want to go by ones, you can use this to help you scale. And what I do is I use some of those points. So I'm looking at it, I can see my 0, 1. You could choose a different scale if you want. At 1, it looks like I'm about a halfway. And then by 4, I'm getting really close to that line. Okay, so that can help you with the shape of your graph. Okay, and then for your domain, you're looking at your input values, your x values. So here, this arrow means x is going to extend to negative infinity. This arrow means your x is going to extend to positive infinity. So your domain is all real numbers. And again, we just need to be able to recognize these in both forms. Okay, set builder notation and interval notation. Okay, and then for our range, we're looking at our y. So the lowest value on y, we just looked at, it's going to get closer and closer to 0, but it's not going to cross it. Do you guys know what's there? Why it can't cross it? There's an asymptote, and that's because this is a rational function. So you guys graphed these last year. Okay, and if you have the numerator is less than the denominator, you have your horizontal asymptote there. Okay, so 0 is less than y, which is less than or equal to, and we know it's equal to because when I clicked on this point, remember it said 0, 1? Or you can click on your point now, so that one is going to be equal to. So it's going to be 0 to 1 is your domain. And once you click it, like you have the little clump there. All right, and then we're going to flip it to the back. So we have increasing intervals and decreasing intervals that we are going to have to identify. So if it is increasing, you're just going to look at the graph and see between which x values is it increasing. So anytime you're finding the interval, you are going to use your x value. Okay, so in order to find the interval, on which a graph is increasing or decreasing, you will use the corresponding x values. Okay, so the x values and now the y. You are going to use the y for something else, okay? Okay, and then if you were going to identify the interval, you would be using these values. These are your x values. So from A to B, this would be an increasing interval. Okay, it starts increasing at point A, and it goes all the way up until you reach part B. Okay, so all of your brackets are going to be hard brackets unless it's infinity for this. Okay, so you're going to keep increasing until you get here, and then it starts to decrease. So your next increasing is going to be from C to D. Okay, so that's another increasing interval. Okay, when it is decreasing, we're going to use these values, B to C. And again, it's always these. So you are going to have some overlap there. It's going to go all the way up to this point, and that's when it starts decreasing. And then it's going to start increasing again. Okay, so with your brackets, there is going to be overlapping at those points. Okay, so we're going to grab another function. It says just use a graphing device, so you can use Desmos or you can use your calc. Okay, I am going to show you both. Okay, and it's okay to go back and forth between what you want to use, because I know sometimes the graphing calculator is easier, like if you're typing in calculations. Okay, other times it'll be Desmos. Okay, so here's my graph, and then if you want your graph to match this window that you have here, just go to your window. This is a 5 by 5, so we can just make this a 5 by 5. I can go by ones. Okay, and in order to help me draw the sketch of this, I'm going to want to find this point and this point. Do you guys remember how to find the max and the midpoints on a graphing calculator? You have to go to second calc, and then you could go to maximum. Okay, so it's going to ask you where is the left of this maximum, and then you're just going to click a few to the left from the top. Then it's going to ask you where the right is. You click a few to the right, and then we're going to try to get right on there. Okay, so that says negative 1.15. We're going to round to 2 decimal places. Okay, and then it's 3.08. 1, 2, 3, so it's really close there. And then I can see it goes through 0, 0. Right, and then let's check out our good buddy Desmos here. Okay, and we're going to do x cubed. Another way you can type this, so I was typing it in with the keyboard before, but there's a little keyboard here. So show keyboard, you could do this, and you could do x, and then you can do to the third. This AB is a power. To the third, arrow down, minus 4x. Okay, and then you can just click this arrow to hide that if you want to see more of the graph, and then we can zoom out so it looks more like our graph that we see. And then, oh, to find these points, I just have to click them. They even put my intercepts on here for me to click, right? 2, 0, negative 2, 0, and here I'm at 1.15, negative 3.08. Okay, so for this one, I would definitely say that Desmos is going to be a little bit easier there. And I'm going to do one curve at a time. Curve that. Okay, and then I'm at 1.15, 1, 2, 3. And here's my other curve. There we go. All right, and then from there, we're going to state the intervals, and it's approximately, whenever we're estimating today, we are going to round to 2 decimal places. Okay, so the hundredths place. is what we're going to round to. Okay, so we could see that this was negative 1.15, 3.08. We could see that this is 1.15, 3.08. So when we're doing our intervals, our increasing interval, we have an arrow here. If you have an arrow, the increasing is going to start at negative infinity. It's going to go up to your x value. So you are only using your x values here. So negative 1.15. Okay, and then there's another one. I just say and. This doesn't mean that you're going to use an intersection, because it's not an intersection. It's just there are two increasing intervals. So you can say and, or you can put like a comma in between. That would be fine. Okay, and I wouldn't mark it wrong if you put like a union there. It's just you're saying these two are the increasing. All right, and then can you tell me what the decreasing interval is? And remember, hard brackets always for that interval, unless you have infinity. Okay, so from negative 1.15 to positive 1.15, that is going to be your interval. All right, and then example 4, we're going to do some more graphing. Okay, so this is u of x. You can put that in decimals if you want, but you don't have to. You can just leave it as y equals or f of x equals. So we have x. And then when you're doing the square root, you're going to have to either utilize the keyboard on decimals, or you can start to type in square root. You can type in SQRT and it will just pop up. Okay, so if I graph this, right, see how tiny this is? I would want to adjust my window. You can zoom in on your graphing calculator. Like that will help you zoom in there. But let's see how we can zoom in with decimals. Okay, so you can either pull up your keyboard, or if you type in SQRT, boom, there it is. Okay, and then we can just zoom in. But right now it just looks so tiny, but let's zoom it in and let's change our scales here. Okay, so I might go like by a quarter on my graph so I can see that. Okay, and if the graph looks different on decimals versus your graphing calculator, go with decimals, because the graphing calculators are limited by their pixels, and so decimals is going to give you a better picture. Okay? All right, so I'm going to just scale this. So I'm going to make this 1/2. This is going to be 1. I'm going to do the same thing here. So really everything I have is going by a quarter there. So at a half, I'm at about a quarter. If you click on the top of that, and you really just have to click somewhere on the area, like, because if you click here, right, it's going to lead you to that maximum value. So So if you click next to it, it would give you this. So will you practice clicking on yours and make sure you can get this 0.75, 0.32. Okay, so at 0.75 and 0.32. And then I have my 0, 0. There we go. Okay, so we're sketching that. Now the directions here are a little bit different, so I'm going to work through those with you. The directions are going to lead you to what form you should be writing this in. So it says find all the local maximum and minimum values and the value of x at which each occurs. The reason why they state it like that is because the maximum and minimum values are the y coordinates and they occur at a value of x. Okay, so the form for this type of question is you are going to write the y coordinate at x equals, or you can say when instead of at. Okay, and then it says that we're going to state it correct to 2 decimal places, which is the hundredths place. Okay, so when we clicked on that, we got this point, which was 0.75, 0.32. So our solution for the local max, and that's all we have in this one. We only have one local max value. I wanted to do one like this that was out of the ordinary because a lot of times you guys see things like this, okay, and then we don't know that cases like this even exist. So you can have cases that are different than the norm. So this is going to be 0.32 when your x value is 0.75. Okay, or you can say at x equals that. So you can either say at or you can say when. Okay, I believe your textbook says the when, which is why I wrote your solution like that. And this one only had one local max. Okay, you can have multiple. Maxima and minima. Okay, this one only happens to have one. Okay, but if there's 2, then you have to find those. Okay, and if there are 2 local max, there's going to be 1 local min. You're going to have that. All right, and then part B says we're going to find those intervals on which the function is increasing and decreasing. And we're going to state those correct to 2 places. Okay, so again, anytime you're doing the increasing and decreasing, think x values. Okay, I know we've written that out at least 3 times now. Okay, it's because when people get to the test, they forget. They're like, do I do the x value or the y value? So these intervals are always going to be your x values. Okay, so we're going to have an increasing interval and a decreasing interval. Again, depending on the situation, you can have multiple, and you do need to label which is which. So what is your increasing, what is your decreasing? Okay, so we're going to increase starting here. Again, we can click on that point in Desmos. Okay, so go ahead and click on that. And it should say 0, 0, that you're right at 0, 0. Okay, we do want to click on it to make sure so that we know that we're not missing a decimal. So it's going to increase starting at 0 and going up to 0.75. All right, and then at 0.75, all the way here, which again, we can click on that make sure it's at 1, 0. Okay, and that means you're going to be going to 1. Okay, and I'm just going to show you real quick on my decimals that I've clicked so I can see you. Okay, so for something like that, decimals is really helpful. All right, how we doing? Good? All right, example 5. So I know story problems can be hard because there's a lot of information, and sometimes there's information that we have to use in a certain way, and other times it's just going to give you context. So this says between 0 degrees Celsius and 30 degrees Celsius, the volume V in cubic centimeters of 1 kilogram of water at a temperature T is given by this beautiful formula, which we will highlight. We are going to be using this. And then what we have to do is we have to find the temperature, okay, at which the volume of 1 kilogram of water is at a minimum. So is a minimum. So when it says find the temperature, okay, you have to find the value of T. And if you look at your equation, T is the input. Okay, so when we're going to find it, that means we have to find the input value, which is the same as the X value when you're using your calculator. Okay, and so if it's a minimum, we are going to find that minimum value of our equation. Now, it says here the volume. So this is just telling you this is what it is. These are the units. It's of 1 kilograms of water. And the volume here is of 1 kilogram of water. Okay, so that's just contextual. That's not something we have to use. And so when it says find the temperature where it's at a minimum, what we're going to do is we're going to find the lowest value of T. When it's between 0 degrees Celsius and 30 degrees Celsius. Okay, because that's what they give you here, between 0 degrees Celsius and 30 degrees Celsius. So whether you are graphing this on Desmos or on your graphing calculator, you can use that to help you adjust your window. So if you know that it has to be between 0 and 30, okay, that's your temperature. You can adjust the window of your X value so that your X's are between 0 and 30. Okay, you can also either zoom in or adjust the window on Desmos by using the wrench. Okay, and then your X, which is your T in this case, is going to be between 0 and 30. And then when you're thinking of a window for this, without even graphing it first, like what is a value that we know is going to be on there? What's a value I can find right away from the equation? Yeah, you can always find your initial value, right? If you plug in 0, we know that this is your y-intercept. So when you're thinking of your y, I would go to at least 1,000 to see the y-intercept, okay? All right, so let's go ahead and plug that in. So again, you can either, well, let's use Desmos. And you can use V. Let's type that in. 1, 2, 3, 4 zeros before the 6, 7, 9. And once you put it in, just remember our last scale was not big enough for this. So I'm going to just keep zooming out until I see, oop, there's a little something. Remember, I'm trying to find the minimum. Okay, so if I'm trying to find the minimum, once I can see that curve, I'm going to adjust it so I can pick out that minimum value there. Gonna find, so the minimum is really close to the y-intercept. So if they give you the 0, just the minimum point pops up as well. Okay, and adjusting on decimals is going to be a lot quicker than on your calculator. And I'm just going to draw like a rough, I'm just going to draw a rough sketch of this. Okay, so you found your min, and we're just going to keep rounding to 2 decimal places, 3.97999.74. Okay, in this case, they were asking for the lowest t value, which is the input. So we talked about how that's going to relate to your x value. Okay, in other problems, they might ask you for an output. They might ask you for the maximum volume or the minimum volume. So you're going to have to interpret what they're asking for in the context. Okay, so we know now that the minimum value occurs when the temperature is approximately 3.97 degrees Celsius. Okay, so we're putting that in our context. T is the temperature measured in Celsius. Okay, and again, you might have some that are asking for the output, so you would interpret that as well. Okay.